Good morning, one and all. You are welcome in lecture number 8, crystal structure. You are familiar that this belongs to B.Sc Physics device products. Paper number 13A, solid state physics. Again, you are welcome in Sanjeevanee Mahavidyalaya, Chapoli, Department of Physics. In this lecture, we are going to study structure of diamond and structure of sodium chloride in detail, their properties, their physical properties, their crystal structure. All these things we discuss now. See, structure of diamond. Diamond has a giant covalent structure in which each carbon atom is joined to how much? To 4 other carbon atoms by covalent bonds. It is a strong bond, as you remember. Each carbon atom is joined to 4 other carbon atoms by covalent bonds. See, I will show you figure so that you will come to know the exact nature. See here, 1, 2, 1, 2, 3, 1, 2, 3, 4. So the 4 carbon atoms are there. I mean, each carbon is joined with the 4 carbon atoms by what bond? Covalent bond. These red colors are shown for covalent bonds. Which one is very strong, you know. The carbon atoms have a regular lattice arrangement. There is no free electrons to move. So this is nothing but one of the properties of diamond. There are no free electrons to move freely. Easily you can remember the property. So with the help of this figure, you will get an idea that this is a carbon and there are 4 neighboring carbon atoms. They are joined. They are combined by covalent bonds. Got it? Now, carbon has an electronic arrangement of 2, 4. In diamond, each carbon shares electrons with 4 other carbon atoms, forming 4 single bonds. 4 single bonds are formed. In the diagram, some carbon atoms are only seem to be forming 2 bonds, even bond or even 1 bond. But that's not really the case. We are only showing small bit of the whole structure. Entire structure it is highly impossible to show you. So this is a giant covalent structure. It continues on and on in 3 dimensions. It is not a molecule because the number of atoms joined up in a real diamond is completely variable, and it depends on the size of the crystal. Now, what are the physical properties of diamond? First one is it has a very high melting point. Very high melting point. It is almost near about 4000 degrees Celsius. 4000 degrees Celsius is the melting point. It is too much. It is very high. 4000 is not good. Next physical property is what? It has very strong carbon-carbon covalent bonds. Very strong covalent bond, already I have told you, it is a very strong one. Next one is, it is very hard due to very strong covalent bonds operating in 3 dimensions. Why it is very hard? Because of strong covalent bonds, they are operating in 3 dimensions. Next one is, it doesn't conduct electricity. Doesn't conduct electricity in the sense, current is not allowed to pass through it. Means current will not flow through it. It is not a good conductor of it. We can say in short, it is not a good conductor of electricity like iron, aluminum, gold, platinum, silver, etc. It is a resistive matter for the flow of electric current. Next one is, all the electrons are held tightly. All the electrons are held tightly between the atoms so that they does not move freely. They does not move freely. There is no free electron. Next one is what? It is insoluble in water and organic solvents. Very important property. It is insoluble in water and organic solvents. Next one is, there are no possible attractions which could occur between solvent molecules and carbon atoms which could outweigh the attractions between the covalently bonded carbon atoms. See, once more I will tell you, there are no possible attractions which could occur between solvent molecules and carbon atoms. No possible attractions in the sense. Why? Its benefit is that because of which could outweigh the attractions between the covalently bound carbon atoms. So there is no possible attraction, that's why it becomes very hard. High covalent bonds are there. So these are the various physical properties of a diamond. Now let's turn to another structure, that is sodium chloride. Sodium chloride structure. You see figure so that you will get an idea about its structure. Here sodiums are shown by golden color, chlorine ions are shown by near about pink, faint blue colors. So what is sodium chloride? It is no doubt a crystalline substance in cubic lattice. What? Lattice is a cubic lattice. Sodium chloride also crystallizes in cubic lattice, but with a different unit set. Next point about this is what? sodium chloride structure consists of equal number of sodium and chlorine ions placed at alternate points of a simple cubic length. Here, very important concept. Sodium chloride structure consists of equal number of sodium and chlorine ions. Here, blue color sodium, pink color chlorine shown here. If we measure the number of sodium and chlorines, then we will come to know that they are equal in number. For example, we see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 sodium. And if we measure these pink colors also, then all the number of chlorine ions and sodium ions are equal in number. Each ion has 6 of the other kind of ions as its nearest neighbors. Each one has how many nearest neighbors? Other 6 of the other kind of ions. This is about sodium chloride. I mean, sodium chloride has a cubic unit cell. We have seen various unit cells. Then it means it has a cubic unit cell. It is the best thought of as a face-centered cubic array of anions with an interpenetrating FCC cations lattice. And the shell of sodium chloride looks the same whether you start with anions or cations on the carbon. Anions and cations, you know, depending upon their positive charge and negative charge, anions and cations are classified. Ions are classified. Here it is stated that the shell looks the same whether you start with anions or cations on the corners. Each ion is having 6 coordinates and has a local octahedral geometry. What? Octahedral geometry. So you see this. Its lattice type is FCC, face center. Crystal system is cubic. Shell parameters A is 5.6402 angstrom. Alternate names, you know, I think most of you are well known about the names: halide, rock salt, sea salt, and table salt, etc. These are the alternate names of common salt, I mean sodium chloride. And here I have shown you the unit cell. This is what type of cell? It is a cubic unit cell. So that we will get an idea. Here A, B, and C. These are the edges are shown. Now let us turn towards the physical properties of common salt. Its appearance is white, crystalline, cubic. Crystal odor, it is odorless. Density is 2.17 as per the CGS unit. Melting point is about 800.70 degrees Celsius in Fahrenheit and Kelvin it is converted. Also available aqueous solution of different concentrations, which is saline solutions. I mean, sodium chloride is available in what? In the form of solutions, we say saline solutions. So here we have completed this chapter, that is crystal structure in detail. So tomorrow we discuss, in next lecture we are going to discuss about next unit number 2, that is bonding in solids, and X-ray diffraction.